So welcome back again to the scientific writing class. Today's topic is about literature search and reference manager software. And I would like to go first into the topic what science writing means. So what is a scientific paper? Scientific papers are for sharing your original research work with other scientists or for reviewing for the research conducted by others. So basically you are sharing your story with the world. And this means that you're presenting scientific evidence and original scientific arguments. You're sharing your work, as I said before. You're reviewing your peers' work. And this could be either a thesis, this could be a research proposal, this could be a book chapter, this could be a journal article, and so on. And the scientific evidence is included in these publications. So this is presented in the primary literature, and it serves to either support or counter scientific theory or hypothesis. It's expected to be empirical, for example, data collections through observations, and the interpretation is in accordance with a given scientific method. Standards vary according to the scientific discipline. We divide it between primary and secondary literature. So again, the primary literature reports original research in scholarly journals, and it contains sections labeled like methods and results. These are articles that report data, and you remember the IMRAD structure, this is typical for this. Then the secondary literature is material that synthesizes, repackages, or references the primary research. And for example, reviews and metadata analysis are included in this. Also indices and reference books, popular periodicals and so on, such as newswork, these are also counted as secondary literature. Literature search. So I'm going to tell you a little bit about the online searches that you can do to find out the background of your research, what is available out there. And there are some online scientific literature databases, such as Web of Science, Scopus, Google Scholar, or Science Direct. There are differences between these different databases. So, for example, Scopus is proprietary. You scan only title, topic, and keywords, and it is available to search the content provided by Elsevier and non-Elsevier. And Google Scholar, for example, is scanning the content in addition to title, abstract, and keywords. So it also scans the paper, for example, and it's available for basically everything that's published online. So see the difference here between the proprietary searching and non-proprietary searching. Difficult word. Very important is you have to identify keywords for your search. This is an example how you would search for an online scientific database, in this case Science Direct. Again, Science Direct is Elsevier, so you have to have an account for this. As you can see here, it says brought to you by the Alfred Wegener Institute. So I logged in from AVI, but you probably log in from Humboldt. And you can see here, you can search for keywords, author name, journal, book, volume. This is also, we talked about this, keywords are very, very important to have for your paper so that any kind of searching algorithm finds your paper. So thus it's important to have your keywords very much defined and very much explicit for the research that you're doing. So this is an example for Science Direct. So again, it's provided by Elsevier. You need an account. And here's another one. This is Scopus. Scopus is also provided by Elsevier. The difference to the Science Direct before is that it not only searches the Elsevier journals, but also all other journals that are available. So for example, if I publish a paper in an open access journal from the EGU, the European Geophysical Union, then I would not find it in the Science Direct database, but I would find it here in the Scopus database. So you see here again, it's brought to by the Alfred Wegener Institute or by the Humboldt University, and again, you have the ability to search here for various either keywords, authors, and so on. And this is the third database I'm showing you. This is the Web of Science. Before it was taken over by Clarivate, it was Thomson Reuters. And this is the big competition to the Scopus database, so it also searches all databases basically. And again, you can do various kinds of searches, including advanced searches. So there's a difference between the searches. Again, the search potentials between the databases, again, the Scopus or Web of Science or the Science Direct. You need an access somehow, so you have to pay for it, whereas Google Scholar is for free. And here are some more potentials. It varies also between the scientific disciplines where people look for. For example, there's one just for medicine, Medline. Okay, when you do the literature search, it's very important that you use boundaries, because if you use the literature search for a paper, you go into one paper, like say one main paper of your background and your interest, then you look into this paper, into the reference list, and you find a lot of papers that this paper is referencing. And you start having the snowball effect that this paper links to more papers and that paper links to more papers. So this is what it means, the snowballing effect, and easily you can have like many references suddenly, and it becomes overwhelming. So you have to set boundaries. And then you also have to set limits to your literature search. For example, you have to say that you can't just read everything what's provided out there. You will miss something. You have to decide why you're reading something. You have to identify the key references. If you have 100 key references, maybe only 2 or 3 are really the key references. And you have to do a decision what to include and exclude. So this is very important when you do this literature search. Identify these boundaries and don't get overwhelmed with this. Some great tools that are offered are provided by the universities. In the meantime, these tools are provided online. This is the Humboldt University Library, and also at the Telegrafenberg, so at the research park here where I work, we have a library that is serving all the institutes. And they also provide services also for, of course, for others from outside. And of interest here is also their search engines they use, because they have one that's called Albert, All Library Books, Journals and Electronic Records, Telegrafenberg. So this, for example, also includes databases, which is of interest for me. Sometimes you just want to look for a data set, and this Albert tool will pick it up, probably. So some words about the reference management software. So no matter what you use, if it's free software or software which you need to purchase, of course you have to think about how you want to use it. You want to use it locally on your computer, or you want to use it versus a browser. So no matter what you use, these software systems are very good because you can automatically load in your paper or your thesis and format the references. For example, I use mostly Word, and whatever you use, you can have the format pre-installed on the software, and then it will automatically format the references for you inside Word. So it has a plugin for Word. You can access your papers from anywhere stored online, depending on what you choose. You can take notes, highlight text, link like other papers. So it becomes a database for you, where you can organize all your references and easily cite them while you write. Very important is that you still have an organizing system in your library. For example, you have to categorize it. And here are some suggestions how you could do it. So you could do it thematic, you could do it by author, by theory, by region, by assessment, by thesis, by data set. Whatever is good for you, you can have groups and organize it. The benefit of this software is that you can import new references directly from these online data bases. For example, I showed you Scopus or the other Web of Science or so. So you import these new papers directly into your database with all the information that's required. Then you can cite as you write. You can automatically create the reference list bibliography in your word processing style. And very important, if you submit a paper and then it comes back, it's rejected, for example, then you can submit it to a new journal, and therefore you have to reformat very likely the references because it's a different journal format, and thus you can just use the software and you don't have to do it manually. I will show you some examples now. This is just an example from my Endnote system. So here you can define groups, but here you see it's a list of, in the meantime, more than, I think, 5,000 references. And the nice thing is that you can attach the papers to it, like the PDF is attached to it. And also this shows you what makes the formatting so easy, because in this case Endnote, you have all the styles in your style folder. So if I want to change from a style format into a different one, I can just load it and then it will automatically reformat your references. And last, this also is not only a database of collections, but also of my memories. For example, if I have a paper that I specifically like, I can highlight the text, or I can make a note, as you can see here. And so it helps me also memorizing which is the relevant literature. Okay, so this is just an example for Endnote. Of course, there are many other software potentials, and you have to pick the one that you like best. There's also the chance that you do an Excel table, and then you import your references using an R style format. This is also done now. Okay, I often get the questions, how many papers is enough? And how much is too little? And that's kind of a balance. This is just showing you an idea how this becomes quickly overwhelming. So you see here, these are the papers that you found on the online databases that I showed you. Then you quickly have the snowballing effect, like one paper links to all these papers and here again, and you see how this is multiplying very quickly. At the end, you have a lot of paper, but when you read this, there's some truth about it. So this is here, total printed or photocopied 248, papers actually read is 107, papers actually understood it's 5. This is actually the relevant papers to your thesis, only 2, and you see those 2. So you really have to balance it and see which ones are important to report. And just one message at the end, you really have to think about, do I collect just papers, or do I collect the knowledge in these papers? Okay.